1. Okay, maxima and minima problems. Now we have looked at the investigation of the Yoast 2 type of drinks. Okay, now in real life, okay, be it manufacturing, engineering or logistics, okay, one often needs to find the maximum or minimum value of a specific quantity subject to some constraints or conditions. Remember the part that we learned about the Yoast drink? Okay, the volume is actually the constant and the surface area can be maximized or minimized in this case, right, for the condition so that the volume remains 250 ml. So we can change the dimension of the cuboid. Now in similar manner, okay, we are going to learn some examples of how this can be applied. Now look at example number 1. Now, it's very important to look the question very carefully first. Okay. Now, there are two positive numbers, x and y. They vary in such a way that x times y is equal to 49. Now, this is the condition. Okay. Another number, z, is defined to be z is equal to x plus y. Okay. Now, are you able to show part 1? Z is equal to x plus 49 over x. Okay. So we write down, we know that if x times y is 49, y must be 49 over x. Okay. And we can actually replace the y from the equation here. Okay. We're going to get x plus 49 over x. Now this is shown with you. Now the part 2, right, they ask you to calculate the value of x for which z has a stationary value. And second part is that you need to show that this value of x that you found is able to make z a minimum. Now, we need to write this statement first. Okay, this is what we have learned. For stationary value of z, dz dx must be equal to 0. So, what is our dz dx? Okay, you should know that 49 over x here. Okay, if you differentiate, you're going to get negative 49 over x squared. And of course, when you differentiate x, you're going to get 1. After that, right, to find the value of z, okay, so to find the value of x for which z has a stationary value, we set this to 0 and we can actually solve it. Okay, it's just a simple procedure. Now, x must be equal to 7 because it is mentioned that x and y are both positive. Now, how are we going to show that this value of z that we find makes z a minimum? Now we have two methods. One is the first derivative test and the other is the second derivative test. Now to choose which one is more efficient or which one is able to get the answer at a much faster, we need to actually check the function dz dx. If you look, this is dz dx, and we realize that this is easy to find the second derivative. So I'm going to use the second derivative test. Okay, so I find the second derivative test. Now how to find the second derivative test? Okay, we're going to write d2z over dx squared. Okay, we're going to actually differentiate this. 1 is 0, right? Differentiate 1 is 0. So here, right, you're going to get negative 49 times negative 2, which is going to give you 98. And then the power of x must be minus 2 minus 1. We're going to get negative 3. So this is actually equals to 98 over x power 3. Okay? Okay, now we are going to evaluate this at x equals to 7. Now this shall be 98 over 7 cubed. Now 98 over 7 cubed will definitely give us more than 0. We need not actually work out the value. we need to know the sign. Because for second derivative test, okay, we need to know whether it's positive or negative, whether it is more than 0 or less than 0. If we got d2z dx squared at when x is evaluated at the stationary value of 7, we get this more to be 0. It means that, remember, when d2z dx squared is more than 0, z must be minimized. Therefore, z is a minimum value, okay, or what we call minimize, at x equals to 7. Okay, this is what we are going to do. Thank you.